In this video tutorial, I hope to show how we can find a vector with its direction from two given components, the x and y components. Because x and y are two directions that we know, the first thing I always recommend for these problems is to draw that triangle out to help us get a better understanding of what's going on. So we have our triangle. The horizontal is our x component, and our vertical is our y component. And we're going to be looking for the resultant vector here. So because this has the standard lettering of f, I'm going to say that our resultant vector will be f vector. Now we haven't gotten to forces yet, but this unit here, in, that does not represent north. In this case it is a unit, and it's a unit for newtons, which is a measure of force. And we'll get to that in the near future. Okay. So, because this is a right triangle, and we know Fy and we know Fx, in order to solve for the magnitude of our resultant force vector, we can simply just use the Pythagorean Theorem, where we have the hypotenuse squared is equal to the sum of the squares of the legs. Solving to get f vector by itself, we get this, and then plugging our numbers in, we get 20,000 newtons squared plus 3,000 newtons squared, and square root the whole value. And we should get a value of 20,223.75 newtons. And so that's our magnitude of our vector. However, we're not done yet. While this is just a magnitude, a vector requires the magnitude and the direction. So in order to do the direction, we can do several different things. We can find the direction from due north, which would be this direction there, or we can find one of the two inside angles, and either would be taken for full credit as the direction, as long as one of those angles is included. Now I'm going to find this angle. That's just picked arbitrarily. You really could pick any angle. The reason I'm picking this angle is so I can demonstrate how we use tangent to figure out the angle from two components. Because we have the hypotenuse, the adjacent, and the opposite, you really could use sine, cosine, or tangent. However, I am going to be using tangent for this example. So in order to find tangent of an angle, we want to find the opposite over the adjacent. In this case, our opposite, look at the angle, the one leg opposite is Fy, and our adjacent is Fx. Okay. Now to solve for theta to be by itself, we want to take what's called the inverse tangent. Now in some math classes you may have said, oh, an inverse, that's just 1 over x, but this is wrong. This is a special function that comes from trigonometry and fancy circles. We won't get into that in this class, but there is a very mathematical reason of how we go about tangent. Your calculator will do just fine to get you the answer, though. So we plug our numbers in. We should have 3,000 newtons over 20,000 newtons. Page up. And you should get that theta equals 8.531 degrees. Now, if you got 0.149 on your calculator, this means that your calculator is in radian mode and you need to convert it to the degree mode. Okay. So now we have our magnitude and our angle. And so a final answer for this type of problem would be that force is equal to the magnitude at a certain angle. Now, it is really important to identify what your angle is in your picture, just so that when it's being graded or you're trying to communicate to a peer, that they understand what you're trying to say. But at the end of the day, this would be an acceptable final answer.